Now let's look at these two questions and let's do some math. So these two questions are still from paper 2010. Should be question 1, 1B and 1C. Okay, for B, the line between NS5 and NS2 is labeled 434 nanometers. Show that this is correct for hydrogen atom. We know that for hydrogen atom, we have this kind of equation. Basically, these two questions are really, all about math. Now we have this kind of thing. Lambda 1 over lambda is going to be R, Rydberg's constant, over S 1 over S squared minus 1 over L squared. Now here we want to calculate. Actually, all we have to do is to calculate the right part so that the lambda is going to be equal to this. Then problem solved. Now we want to calculate it then. It is going to be Rydberg's constant is 1.097 times 10 to the power of 7 times 1 over 2 to the power of 2 minus 5 to the 1 over 5 to the power of 2. So this is going to be your actually 1 over lambda. So your lambda is going to be 1 over all of this thing, right? It is going to be 1.097 times 10 to the all we have to do is to write it like this so that we can calculate the lambda directly. Let's use our calculator. So what we want to do is that we want to calculate 1 over 1.097 times 10 to the power of 7 times, not this times, times 1 over 2 to the power of 2 minus 1 over 5 to the power of 2. So it is going to be calculated. We want to convert it into decimal. It's going to be 4.34 times 10 to the power of negative 7. So it is going to be 4.34 times 10 to the power of negative 7. Exactly what is written here. So problem solved, right? Yeah. Meters. Great. Now let's look at part C. Calculate the energy of hydrogen atom in its ground level. For ground level, we know that your N is going to be equal to 1. So we can use, now this time, we can use this formula or this equation. We use this equation to calculate the concrete value of each energy level. We use this one. HCR over N to the power of 2. Now since your N is 1, so we have ground level 1 is going to be negative CR over 1 is going to be negative HCR, and all of these are constants. Express your answer in evolts. Okay, so let's calculate it in joules and then convert it into like evolts. So it is going to be, you know what? Let's directly convert it. Okay, I think you only have to do something like this. So yeah, never mind. We calculate this first. Negative h is going to be Planck's constant times c speed of light, 3 times 10 to the power of 8, times r Rydberg's constant, 7. It is going to be equal to, let's calculate this, 6.63 times 10 to the power of negative 34 times 3 times 10 to the power of 8 times 1.097 times 10 to the power of 7 it is going to be like this. And we want to divide this value by, we give it an answer. Where is our shift answer? 1.6 times 10 to the power of negative 19. So let's remember two values, 2.18. Okay, 2.18 and 13.6. 2.18 times 10 to the power of negative 18 joules. It is going to be equal to 2.18 times 10 to the power of 18 over 1.6 times 10 to the power of 19, 13.6 evolts, and the answer should be negative because we know that at ground level or level 2, level 3, level like, yeah, we know that all of these energy levels are in negative numbers, in negative values, except you know that level infinity, which has energy level 0. So it is going to be negative 13.6 volts. Problem solved for these two.